meaning of bisector line containing a point. Let's say this is bisector 1, sorry, this is line 1, L1, and this is line L2, guys. So this is L1, this is L2. Okay, now this, if I draw one line like this, so this is bisector line. Now this is the, what I call, this is the region of the bisector. So if a point is, let's say point A alpha comma beta, if it is here, 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 in fact it can be on the bisector line also, here, 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 A alpha comma beta, here, anywhere in this region, then we say that A alpha beta is contained by, A alpha beta is contained by this bisector. Let's say this is bisector B1. Similarly, if suppose A is here somewhere, then we will say that it will be contained by this bisector. Okay, so that is the meaning of this. So A alpha beta is contained by bisector means A alpha beta lies in the region of the bisector. This is how we define the region of the bisector B1. This is the region. Okay. Now how to find the equation of bisector line which contains the point A alpha comma beta? Let's see that, guys. So let's define this L1 x comma y as the expression of the line, which means a1 x plus b1 y plus c1. L2 xy is a2 x b2 y plus c2. This is the expression of the line L1. Line L2 expression is this. Okay, guys. So it can be positive, it can be negative, it can be equal to 0 also, guys, depending on whether the point lies on which side of the line. It can be equal to 0 if it is what? If it is lying on the line. Okay, so these are the that's how we mean L1 xy as this and L2 xy as this. Okay, now if this is line L1, guys, okay, so this side of L1, this side of L1, guys, is positive, for example. So this side of L1 would be what, guys? This side of L1 would be negative. So all the points on this side, like if you take L1 on this side also again negative, and here also L1 on this side, it would be positive only, guys. L1 would be positive. So now let me draw another line which is what I call as L2. So guys, this is L2. Okay, this is L2 line. This is L2 line. So let's say if L2, this side, if suppose it is positive, so L2 positive, L2 positive here also. So this side it would be what, guys? L2 would be negative. This side also L2 would be negative. this side it would be positive and this side would be negative. Okay, L2, this is plus plus on this side, and on this side L2 is negative. So guys, this is negative. Okay, this is negative. So now if I draw, now if I say point A is somewhere here, A alpha comma beta, or if it is here or here or here, then if I draw a bisector uh, like this, then we can say that, let's say this is bisector B1 or B2. Okay, name doesn't matter. So let's say this is bisector B1, so we will say that A alpha comma beta, whether it is here, here, here or here, it will lie in the, it is contained by B1, guys. Okay, now the question arises how we can find the equation of the bisector which is contained by A alpha comma beta. Now in this particular situation, as you can see, L1 is giving positive and L2 is giving negative, and as well as the same sign would be given by any point P on this bisector whose equation we are interested to calculate, to find out. So what we will do, we will draw perpendiculars from this on this. From locus concept we know that since this angle is same, this distance is same as D and D only, guys. Okay, so D in this case, let's say PM, and this is PN. PM would be calculated how? Calculated by PM equals to D would be, since L1 is positive in this case and L2 is negative, so D, this PM would be given as what? Distance from line L2, it would be, since P would be giving which sign, guys? P and A are on the same side with respect to line L2. Okay, so on this side L2 is giving negative, so PM would be minus L2, because D, since D is positive and L2 is negative, so in order to balance it we have to multiply by minus sign upon under root is equal to, similarly PM is equal to PN. Again we have to write L1, because this is PN is distance from L1 and L1 on this side is positive, guys, so we will write L1 by under root. Under root means what? Here under root we mean by that coefficient square, like A2 square plus B2 square. Similarly here also we can write A1 square plus B1 square. Okay guys, so in short, the sign given by, this is the bisector equation, guys. This is the equation of the bisector B1 which is contained by A, but the question is which sign A is giving. So A is giving the same sign as P is giving, guys, because A and P are on the same side of L2 and A and P are on the same side with respect to L1. So A will give which sign, guys? If you substitute alpha beta in L1 and alpha beta in L2, you will get negative sign, and corresponding to this is the bisector equation. So what I mean to say is this, guys. What I mean to say is if L1 alpha beta and L2 alpha beta is giving opposite sign, plus minus minus plus, then the bisector line which contains this point alpha beta would be given by L1 by under root minus L2 by under root. Okay, in the similar way we can prove that if L1 alpha beta, L2 alpha beta, the sign given by the point A to the given lines, their product is positive, means if it is giving both plus plus or minus minus, so then the bisector line containing the point A alpha beta would be given by what? L1 by under root inside is same, the coefficient a1 square. L1 I mean is L1 x comma y, guys. L2 x comma y. So under root is what? a1 square plus b1 square. And here, yes, it is plus sign, we will take L2 by under root using the similar reasoning, guys. So that's how we calculate the bisector line containing a point. We just substitute the point alpha beta in the two lines and check whether they are giving opposite sign. If opposite sign, then L1 by under root equals to minus L2 by under root. We will, using this we will get. Otherwise, if it is positive, their product is positive. Once we substitute a alpha beta in the line expressions, then the bisector line containing the point A alpha beta would be given by L1 by under root equals to plus L2 by under root. Okay, that's how we calculate, guys.